We are the Volcano Snails.
And today we would like to introduce you to volcanoes.
And how they turn from this to this.
In order to understand how volcanoes form, first we must talk about plate tectonics. The Earth is made of four layers: the crust, mantle, outer core, and inner core. Plate tectonics is the theory that Earth's outer shell, the crust, is divided into plates floating on top of the mantle and they can move around. There are three places where plates interact. At divergent boundaries, plates move away from each other. At convergent boundaries, plates meet and create a subduction zone. At strike slip boundaries, plates move past each other. When inside the Earth, molten rocks are called magmas, and when they reach the surface, they are called lava. Lava is made of different compositions based on where they are formed. Toxic continental crust, mafic oceanic crust, and intermediate when the two mix together. At divergent boundaries, lava continuously flow up between the separating plates to create new ocean floor. The mid-ocean ridge is a large fission volcano that extends across the Atlantic Ocean. In subduction zones, this crust slab that goes underneath the other plate will get hotter because of the surrounding hot mantle. The slab heats up, turns into molten rock, and rises through the surface and form a place of volcano. Hotspot is a real special place to find a volcano as it is a hotspot within the mantle underneath the crust that pierces through the crust to form volcanoes such as the Hawaiian Islands and Yellowstone. So, let's see how they form.
First, we'll observe the science behind mantle plume that creates shield volcanoes using a simple at-home experiment. If it is hot, where does it go? All we need is a red food dye, one empty small glass, a big glass of cold water, hot water, and a pair of tongs. Pour some red dye into the small glass, and then we will carefully add hot water with the help of an adult. This red liquid will represent hot magma, and cold water in the big glass container represents the atmosphere. To recreate a rising hot mantle plume, carefully pick up the small glass with the tongs and immerse it in the big glass vertically. So immediately what we can observe is that the hot red liquid staying on the surface of the cold water, and it does not sink beyond the height of the small glass. This shows that heat rises, goes up, and remains at the surface. Hot magma that rises towards the surface in the volcano, just like the hot red water in the small glass. Using the Google Earth application on my computer, I will be traveling from UCLA, which is where I'm from today, all the way to Hawaii, which is located in the Pacific Ocean. And the island of Hawaii, which is the youngest island within these clusters of islands, is Kilauea, and Kilauea holds a culturally significant spot in Hawaiian traditions, as it is home to a deity named Pele. Pele is the goddess of volcanoes and fire and the creator of the Hawaiian Islands. The Hawaiian Islands volcanic chain were created as she tries to find a new home after fights with her sister, Namakaukahai, the water goddess. To explain real events in this volcano's history, oral traditions speak about Kilauea as home of Pele. She is believed to govern Kilauea and live within the Halemaumau crater at the summit of Kilauea, and is responsible for controlling its lava flows. Indigenous people have long used such oral histories to record natural disasters, like volcanic eruptions and lava flows, much like what we can do today with GPS and photos taken from satellites. As we can see from this satellite image, the volcanoes in Hawaii are actually bigger than the tallest mountains in the world, but most of the body of these volcanoes are hidden underneath the ocean, just like an iceberg. The reason why this is possible is because of the hot spot underneath, just like we showed you in the demo earlier. Hot lava rises from the hot spot to the surface and cools down while staying on the surface. Eventually, the plate moves along this hot spot, creating this chain of volcanoes. Kilauea is located on the southern part of Hawaii and is currently an active volcano. Kilauea is still erupting lava actively as of today, March 9, 2021. Kilauea is actually 4,000 feet tall, and most of its surroundings are covered by layers and layers of solidified lava from a long history of eruptions. It also has a classic volcano shape for a shield volcano, with shallow slopes and topographically flatter than other types of volcanoes. It also has a large crater in the summit, which used to be filled by water, but since the recent eruption, the lake actually has turned into a lava lake, as we can see here, shown by this image.
What is a cinder cone volcano? Cinder cone volcanoes are tall, cone-shaped volcanoes. They have a bowl-shaped crater on top and a vent in the center. When they first form, they are quite small, however they can grow up to about 1,000 feet tall. Eruptions from this volcano are similar to what happens when you shake and then open a soda bottle. When you shake the bottle, the outside feels very firm, and if you open it, the soda will explode everywhere. This is because gas will build up in the bottle as you shake it, which causes the pressure inside to rise. When you open the bottle, the high pressure will aggressively force the soda out of the bottle opening. This is exactly what happens in a cinder cone volcano. Over time, gas builds up in the central vent and increases the pressure, causing highly explosive eruptions. I have prepared 2 experiments to demonstrate how a cinder cone volcano erupts and how its outer cone shape forms. These are the materials needed to do both experiments. For the first experiment, create a model volcano out of Play-Doh or clay. Add baking soda and red dye to the center of the volcano. And then pour in some vinegar. As the lava pours out of my volcano, I am throwing pom-poms into the air. Cinder cone volcanoes not only erupt lava, but they also fling volcanic rocks, called pyroclasts, into the air. These pyroclasts are what actually forms the volcano's outer shape. The second experiment uses popcorn to show how pyroclasts form the cone shape of the volcano. Simply drop popcorn onto a table. As you continue to drop the popcorn, a small mound will form. Notice that after a little while, parts of the mound will fall down instead of getting steeper. This is because all particles have an angle of repose, which is the steepest angle that the material is stable. When the popcorn pile gets steeper than the angle of repose, the popcorn will fall down. Now let's watch a short video of an actual cinder cone volcano erupting. Next, we will visit Cinder Cone Volcano, located in Lassen National Park in California. But first, a quick history lesson of the national park. Lassen is located in Northern California and is one of California's 9 national parks. It contains 4 different types of volcanoes. Lassen National Park has a rich history of indigenous culture. Lassen Park's cold weather and snow, high elevation, and migrating deer populations made it difficult to live in all year round. However, at least 4 different Native American tribes camped near the creeks and lakes in Lassen during the warmer seasons to hunt and gather the many resources found in the area. The 4 tribes were the Otsugeri, Yana, Yahi, and Maidu tribes. Lassen also has a complex geological history. Many geological landmarks in Lassen National Park formed due to the ancient subducting Farallon Plate. This oceanic tectonic plate subducted, or sank, under the North American continental tectonic plate, which caused all of the volcanoes in the park to form. Because an oceanic plate subducted underneath the continental plate, the lava that erupts from the volcano is intermediate lava. Now, let's take a trip to Lassen National Park through Google Earth. Here is the volcano itself. Notice its large central crater. If we turn the camera on its side, we can see its distinct conical shape. Lassen volcano is only about 750 feet tall, and its last eruption was in the year 1666. The black rock surrounding the volcano is called the fantastic lava beds, which form due to eruptions from the volcano. If you ever go to Lassen Park, you can actually hike up Cinder Cone Volcano and into its crater. The trail is about a 4-mile round trip and will take about 3 hours to complete. Here is a quick video showing the hike.
Nabila and Amanda have already shown you volcanoes that look like mountains. Now, let's talk about a gigantic eruption that empties a magma chamber and builds a big hole, which we call a caldera. We can learn the caldera mechanism by doing calderas in a flower box. Materials that we are going to use are a box, flower, a balloon, and an air pumper. First, I attach the air pumper and the balloon at the bottom of the box. The balloon represents the magma chamber. Then I dump the flower which imitates the earth into the box. I pumped the air into the balloon to illustrate how air or magma filled into the chamber. You can see that the magma inflated the ground and cracked the surface. With more magma, you're gonna have a small mountain. Then I suck the air from the balloon. You can see air rushing out, which illustrates how lava gases rush out when there is an eruption. And here is a crater left behind the eruption. And this is how the calderas are formed. Now we are taking you to the Yellowstone National Park, representing one of the greatest caldera volcanoes in the world. Yellowstone consists of 3 calderas coming from the 3 largest eruptions. Some call Yellowstone the supervolcano due to the size of its major eruption. Compared to others like Lassen Peak, the volume of material ejected from the first Yellowstone eruption is around 400,000 times larger. These eruptions are related to hotspots formed under the continent. About 16 million years ago, the hotspot begins under the area near Idaho. The movement of the North American plate created the volcanic chain and brought the Yellowstone closer to the magma body, and 2 million years ago the first eruptions in the area happened. And the magma chamber have sit beneath the Yellowstone until the present day. You might not see the big holes right now because lava from later smaller eruptions filled in the caldera floor. One of the important features here is the thermal feature. Because the hot magma chamber is still located beneath Yellowstone, it is heating shallow water reservoirs and resulting in the hot spring like the Grand Prismatic Spring and the geyser like the Open Full Geyser. Now I will tell you the fun fact of Yellowstone. Do you know why Yellowstone is called Yellowstone? Many people believe that this name comes from the color of lavas altered by reacting with water. But in fact, the name was attributed to Native Americans who revered the color of stones along the Yellowstone River, located several hundred miles downstream of the park.
Hi everyone! We hope you had fun learning about volcanoes with us. Before we go, we want to tell you why we're named the Volcano Snails.
If any of you have played Pokemon before, you may have encountered the fire type called Magcargo. It's a lava snail.
You may think that snail is only in a video game, but it actually exists in real life. The scaly foot snail lives around deep ocean hydrothermal vents.
It makes its shell out of iron and its body is a deep red, just like the Pokemon.
This has been the Volcano Snails. Thank you for watching our video.
Stay safe, wash your hands, and keep learning about science.
Bye!
Woo!